All right, good morning, my Algebra 2 students. This is day 3 of the log notes. I feel like it looks a touch blurry, but hopefully you can still see well enough. I can't seem to get it to focus any better than it is. So what we're looking at for today, there's 3 different properties that you have to know how to use with logs to be able to kind of manipulate, change them around, and so on. So what this page is it's asking you to evaluate a bunch of really simple logs, and then we're looking for a little pattern. So you might actually be better off seeing if you can pause the video, calculate each one of these things, and then look for the actual rule. So here's your chance to hit pause. Otherwise, I'm going to keep going. So you can go with me, but I'm going to go quick. So for each one of these, if I evaluate, so log base 2 of 4, that means if I did, and I'll do the work off to the side here, log base 2 of 4, if I set it equal to x, we learned yesterday that I can exponentiate to rewrite this. So this would be 4 equals 2 to the x power. So x would have to be 2. So 2 squared is 4. So that's equal to 2. Right? So I want you to do that with each one of these. So like this next one, you're really saying 2 to what power would equal 8? Well, 2 cubed would equal 8, and the log is always the exponent, so that would be 3. And then here, they're just simply asking you to add them together. So this is like saying add 2 plus 3, and ta-da, you get 5. And then evaluate this last one. If you do log base 2 of 32, that's the same as saying 2 to what power equals 32. You guys know your powers of 2. That exponent, that would need to be a 5, all right? 2 to the 5th power equals 32. So what they're trying to show you here is what's happening. Well, if you evaluate them individually, you add them together, you get 5. You come out with this. All right, well, how is that helpful at all? Well, think about what 32 is. 32 is equivalent to 4 times 8. Right? So if you multiply these two parts together, you get 32, and you get the same answer as if you had added the logs themselves together, which kind of follows that rule of when you're working with multiplying bases, you add the exponents, same idea. When you multiply this part, you end up just adding the value. So the way we can write the rule is to say, in general, if we do log base b of x plus log base b of y, it'll give you the exact same answer if you had multiplied x and y together and then taken log base b of that. So there's your first rule. You can pause here again and calculate the second ones, or you can just roll with me on it. So again, we're evaluating log base 2 of some simple logs here. I'm going to slide on up. So for the next one, log base 2 of 16 is the same as saying 2 to what power is 16. So we know that that exponent is 4. Here, this is like saying 2 to what power comes out to be 2. Well, that has to be a 1. And now take the difference. So 4 minus 1 is simply just 3. And then come over here. If I do log base 2 of 8, we did that one above. We know that that one comes out to be 3. But what does 8 have to do with it? Well, when you come back here, you had 16 and you had 2. So where's the 8 coming from? 8 is 16 divided by 2. So how does that play into the rule here? Well, they want you to figure out what's the rule when you have x over y. Well, hopefully what you can see is when you take the difference, that's going to be equivalent to when you take the quotient and then evaluate the log. So I'm going to write that again, generic, as log base b of x minus log base b of y is equal to log base b of x divided by y, just like that. As for the last one I'll do with you, so I would say don't pause the video on this one. For this, I want you to take this first part, and let's keep this and evaluate 4 cubed first. So we know 4 cubed is 64, which means we have log base 2 of 64. Right? What's that equal to? Well, that's the same thing as saying, 3 throw an X over here. If I do 2 raised to the left, 2 raised to the right, this is the same as saying 2 to what power would give me 64. You might have to think about that one or use your calculator, but 2 to the 6th power is 64. So the answer to this is 6. This would be equal to 6. Over here, what it's saying is let's evaluate this part first. All right, well, that part alone is the same as saying 2 to what power is equal to 4. That would be a 2. And then multiply it by the 3. Look at what happens. Ta-da! Same answer. There's that 6 again. Okay, how do I turn that into a rule? Well, what's the difference between them? They were both log base 2 of 4, log base 2 of 4. The 3 moves spots. The 3 moves from the exponent here out to being the coefficient here. And that's actually the rule. So if you have log base b of x raised to the y power, you're allowed to take that y and drop it out front so that it becomes y times log base b of x. And what that's really similar to is power raised to a power. You multiply, same idea here, all right? So those are your 3 rules. As you're moving through this, you might need to flip back, but the basics are, if you're multiplying 2 things, you can split it up into addition. If you're dividing, you can split it up into the logs using subtraction. If you have a power, or if you have something raised to a power, you can take that exponent and drop it out front. There's the quick way to think of it. So the first one, we have a and b multiplied together. So when you think we're multiplying bases, we would add exponents, means we're going to add the logs. The base is arbitrary. Just keep the base with it. So it would be log base 7 of a plus log base 7 of b. That's it. That's all you have to do. So you're using the rule that when it's multiplication here, it switches to addition over here. For one like this, just for these first few, do it in 2 steps. What I mean by that, I see this as a multiplication problem again. So I'm going to start by splitting it into addition. So it'd be log base 5 of a plus log base 5 of b squared. Now I've got a second thing that I can take into account. I've got the exponent up here. That third rule we talked about is that exponent can come and drop out front. So this is really log base 5 of a, and then plus 2 times log base 5 of b. And there you go. That would be my fully expanded log property. Let's see. As a little hint for number, let's see, I'm going to jump down to number 4. With number 4 here, we have to rewrite the cube root of x. Oops, let me slide. Sorry, wrong way. Rewrite the cube root of x using an exponent. So from the last 2 units, you know that that's a fractional exponent. Power of 1, root of 3. So it's the same as x to the 1/3 power. If I think of it that way, as log base 7 of x to the 1/3, then all I'm really doing is taking the exponent and dropping it out front. That's it. So this piece is going to drop out front and be 1/3 times log base 7 of x. That's it. So I challenge you to try the other ones. Number 5 is definitely a good challenge. So we're going from expanded form back into, can we write it as a single logarithm? So the very first one thing at a time. What I want you to look at this is I see 2 separate logs and I see subtraction. So what I know, I subtract exponents when we're dividing bases, which means we have to do the log using division. So that means I'm going to do log base 3, and I need to go in order from left to right. So from left to right, that means numerator, denominator. So it's going to be 2 divided by x. Right? So the rules aren't tough. They just take some practice. And then the bigger and more complicated these are, you got to think about kind of order of operations. So when I look at this next one, if you have numbers out front, multiplication, when you think of PEMDAS, would happen before any addition would. So I have to deal with these first, all right? So I'm going to say the exponents first, because hopefully what you know is that that 3 is going to come back up and be an exponent. That 2 is going to come back up and be an exponent. Right? Now, something that sometimes gets asked here, so I want to be very careful about how I write this, right, is that the whole log is not going to get cubed. It's the 2 inside the log that's going to get cubed. So when I do this, this is going to turn in, let me see if I can zoom this just a smidge. There we go. It's going to look like log base 3 of 2 cubed, and then plus log base 3 of x squared. So same thing, the 2 is cubed, the x is squared. And since the 2 is cubed, we can clean that up. That's log base 3 of 8 plus log base 3 of x squared. All right, now we get to use our other rule. If these are split by addition, we are going to bring them back together using multiplication. So make it one single log. I'm not multiplying the logs together. The goal is to make it one log, and on the inside should go 8 and then times x squared. So that is perfectly fine to leave your answer like that. It looks a smidge clunky, so I'd probably rewrite it and make it log base 3 of just 8x squared like that. But that should be my answer there. Let's do one or two of these. So little challenge with these. It's saying to you, it's like a little substitution problem. It's saying if A is equal to the log of 2, B is equal to the log of 3, write each expression in terms of just A and B. So like final answer should look like A minus B or A plus 2B, but there should be no more logs in the answer. Right? So what we're actually doing, it's like a challenge of what we looked at like on the front page almost. So in this case, what I really want you to think of is if I see this 6, how do I make 6 using a 2 and a 3? And hopefully what you're thinking in your head right now is like, all right, 6 is just equal to 2 times 3. So let's rewrite the log as 6 is 2 times 3. So I'm going to rewrite it as 2 times 3 like that. And now here's where the rules come in. If this is multiplication, think you multiply the bases, so you add exponents. Same thing here. If I'm multiplying inside the log, then I'm going to split it into 2 separate logs using addition. Right? Now I can actually make the substitution. Log of 2 is equal to A, and log of 3 is equal to B. So there's my answer. It's literally equal to A plus B. There you go. All right. Some of these, there's different ways that you can do it. Like a simple one would be like if I'm looking at C, nothing super crazy there. All I have to do is be able to separate it into 2 separate logs. So since I have log of 3 halves, this is division. We know that that means you subtract exponents, so we subtract the logs. So this is log of 3 minus the log of 2. And then I can plug in, that's B, that's A, minus sign in between. So this is literally B minus A.